Hello everyone, welcome to a new video of our series Enzyme Kinetics. In last video we have gone through the enzyme kinetics part, that is Michaelis-Menten equation, and how to determine rate of any reaction. And today we'll go through different kind of plots which are required to identify those things, to characterizing any enzyme in a reaction. Last class what we have read? We read enzyme kinetics, which basically defines rate of a enzyme reaction. And how we define it? V equals to Vmax is divided by S plus Km. From this, we can identify one thing. This Vmax and Km. These two are sort of constant sort of thing. And these two are basically the key characteristics of any enzyme. And the rest of the thing, we can alter these are parameters. Thus, we need to identify Vmax or Km to characterizing any enzyme kinetics reaction. From these, the plot we have received, that is a hyperbolic plot, which is this. Like this is S, this is V, this is called Vmax, and here somehow Vmax by 2, that is substrate, that is Km. But from this plot, it is not possible to specifically calculate these two values, Km and Vmax. Thus, we need to somehow alter this equation. Thus, we can identify those two values. And for identifying any values from a plot, the easiest plot is straight line plot. There are three plots which are actually useful for identifying Vmax and Km. The most popular one is Lineweaver-Burk plot. Second one is called Hanes-Woolf plot. Hanes-Woolf plot. And the third one is called Eadie-Hofstee plot. Eadie-Hofstee plot. This Lineweaver-Burk plot, this is also called as double-reciprocal plot. Double-reciprocal plot. And both two are single reciprocal plot. The reason is like this Lineweaver plot, sorry, this spelling is wrong. In this equation, we plot 1 by V against 1 by S. But in this Hanes-Woolf plot, we plot S by V against S. And in this Eadie-Hofstee plot, we basically plot V by S against V. Here you can see both are reciprocate. Thus double reciprocal. In this only one reciprocating value, that is single reciprocal. First talk about Lineweaver-Burk plot, which is most important, which is called double reciprocal plot as well. The derived thing, V equals to Vmax is divided by S plus Km. Reciprocate this equation is stood like 1 by V equals to S by Vmax x, that is 1 by Vmax plus Km by Vmax into 1 by S. Here you can see the equation stand like y equals to this is a constant m x plus c. Now plot then this is Lineweaver-Burk plot. How it will be looks like y equals to mx plus c. There is some intercept as well, right? This then the equation will be like this: y axis 1 by v, x axis 1 by s. This is intercept. This point is called 1 by Vmax. Okay. Now m equals to slope, that is tan inverse value. This slope. If you more simplify these things, then this point will be seems like this point minus 1 by Km, because this is slope. From if we go to trigonometry, apply the value of tan x, then we got this point. When x equals to 0, then it will be like y is very simple. Just put a value of this x. This is 1 by s, right? This is x. It is as 0. Then you can get the value from this slope basically. From this slope parameter, you can get it. That is, this is Lineweaver-Burk plot. From here, we can easily identify what is the value of Vmax, what is the value of Km. Next, Hanes-Woolf plot. Again, the equation is like we need to keep the fraction as s by v, right? Then what we can do for Hanes-Woolf plot? We need s by v. Simple. Keep it in downside. S plus Km equals to Vmax into S by V. Here you can understand from there we can also simplify the equations like with y equals to Km by Vm, that is C plus S by Vm. Y equals to Mx plus C. If we plot this equation, it will look like what? It will be equation. It will be a plot like this. Y equals to what? This fraction is y is by v, and the x is what? S. It will be like this. And what is the slope value? Km by Vmax. And if you simplify the equation with the tangential value, then you can get the value of these as well. Right. Now go to next part. Now you can add this double reciprocal plot. This is mostly used. These are the other plots which are also applicable, but not majorly used. Majorly is this Lineweaver-Burk plot is mostly used. And then last one, Eadie-Hofstee plot. Eadie-Hofstee plot. Now, what is this? V by S versus V. This is another very simple thing. What is the equation? Basically, V equals to Vmax S by S plus Km. Right. We need to it keep like in a different form. That is V by S. Just simplify the equation. equals to oh sorry, I missed a step. At first, simplify the equation. That is Vs plus Km V equals to Vmax is right. We need to the equation as like what? V by S versus V. Now keep it S in downside. That is S in downside means that is V plus Km V by S equals to V max. Right? Is it am I right? Yes. Now the equation is like what? V by S versus V. It will be like the equation is now V will be in this side. Right? Then if we V by S equals to Vm, that is V max by Km. This Km come downside. This is a negative part minus V by Km. Oh, sorry, change the color. And the plot will be like here slope is negative. This is the most interesting part. Here slope is negative. Simple. Y Mx C. This slope is negative. Now what is the y? V by S. What is x? V. And what is the intercept value? This is the intercept value, that is Vmax by Km. And what is this? What is the slope? Minus 1 by Km. And simplifying the equation, we can get the value of Vmax is like this. This is the Vmax. Okay, these are three different plots which are basically used to identify the values of Km and Vmax, which are basically characteristic part of this any enzyme. Thank you.